Hello and welcome. In this lesson, we are going to discuss Amazon Elastic Container Service, Amazon ECS. We will talk about what this service is, benefits, use cases, and how it works in an application environment. Let's dive into it. Amazon Elastic Container Service, Amazon ECS, is a fully managed, highly scalable, high-performance container orchestration service that supports Docker containers. Amazon ECS allows you to easily run and scale containerized applications on AWS. You don't need to install and operate your own container orchestration software. In addition, there is no need to manage and scale a cluster of virtual machines (VMs) or schedule containers on those VMs. Let us talk about benefits of Amazon ECS. Amazon ECS offers the following benefits for your organization: managed container orchestration service, highly available and scalable, extra support for AWS Fargate, and integrated with AWS services. Let us explain each of these benefits. Managed Container Orchestration Service. Fully managed container orchestration service makes it easy to use containers to deploy and manage long-running applications, services, and batch processes without needing to install, operate, and scale your own cluster management infrastructure. Highly available and scalable. Maintains application availability and allows you to scale your containers up or down to meet your application's capacity requirements. Extra support for AWS Fargate. When used with AWS Fargate, Amazon ECS allows you to deploy applications without needing to provision, manage, or scale compute infrastructure, reducing the time it takes for you to build, deploy, or migrate your containerized applications successfully. Integrated with AWS services. Amazon ECS is integrated with familiar features like ELB, Amazon Virtual Private Cloud, VPC, IAM, Application Auto-Scaling, Amazon CloudWAS, and Amazon Elastic File System EFS, meaning that you don't need to build or maintain generalized abstractions. Now let's talk about use cases for Amazon ECS. Amazon ECS supports the following use cases, which cover the need of a broad spectrum of customers: modernize applications, automatically scale web applications, support batch processing, and train NLP and AI ML models. Let us elaborate each of these use cases. Modernize applications. Empower developers to build and deploy applications with enhanced security features in a fast, standardized, compliant, and cost-efficient manner with Amazon ECS. Automatically scale web applications. Automatically scale and run web applications in multiple availability zones with the performance, scale, reliability, and availability of AWS. Support batch processing. Plan, schedule, and run batch computing workloads across AWS services, including Amazon Elastic Compute Cloud, EC2, AWS Fargate, and Amazon EC2 Spot instances. Train NLP and AI ML models. Train natural language processing (NLP) and other artificial intelligence or machine learning models without managing the infrastructure by using Amazon ECS with AWS Fargate. Excellent. Now let us see how Amazon ECS works in a typical application environment. Simply describe your application and the resources you required, and Amazon ECS will launch, monitor, and scale your application across flexible compute options with automatic integrations to other supporting AWS services that your application required. Perform system operations such as creating custom scaling and capacity rules, and observe and query data from application logs and telemetry. The diagram is created by Amazon Web Services. The diagram shows how Amazon ECS launches, monitors, and scales applications across flexible compute options with automatic integrations to other AWS services. Developers describe their applications and the resources they need and let Amazon ECS do the rest. Operators perform system operations such as creating custom scaling and capacity rules, and observe and query data from application logs and telemetry. 3 sections display in the diagram from left to right. The first section has an illustration of 2 different personas placed vertically, one below the other. The illustration on top of the section is titled Developers. The description says, describe your application and the resources it needs, then let Amazon ECS do the rest. The illustration below is titled Operators, and the description says, create custom scaling and capacity rules, observe and query data from application logs and telemetry. Both illustrations have arrows that point towards the second section. The second section has an illustration of an icon that represents Amazon ECS. The section is titled Amazon Elastic Container Service. There are 2 arrows pointing to different parts of the third section. The first arrow on top is titled Configuration, and the second arrow below is titled Deployments and Scaling. The third section has 2 parts within it. The first part on top is placed in front on the arrow coming from the second section titled Configuration. This part is titled Automated Integrations with Other AWS Services. Nearby icons show different AWS services: Elastic Load Balancing, AWS Secrets Manager, and Amazon Elastic File System. The second part within the third section is placed in front of the arrow coming from the second section titled Deployment and Scaling. The part is titled Flexible Compute Options. Nearby icons show different AWS compute options: AWS Fargate, Amazon EC2 Graviton, Intel, Amazon ECS Anywhere, AWS Outposts, AWS Local Zones, and AWS Wavelength. There is an arrow pointing towards this list from a nearby illustration on the right. This illustration is titled Amazon Elastic Container Registry and says, build and store container images using Amazon ECR or other container images. We recommend you read the diagram and get a better understanding of how Amazon ECS works in a typical application environment. In conclusion, use Amazon Elastic Container Service, Amazon ECS, and run highly secure, reliable, and scalable containers. That's all for Amazon Elastic Container Service, Amazon ECS. Thank you and see you in the next lecture.